This is problem 3 on chapter 15 from Stats Modeling the World, the author's BVD. So here we've been given some information, and what I'm going to do is just sort of document the given information. Then we're going to answer these questions. So the information is about homes, and it looks like 64% of the homes for sale have a garage. So I'm going to say probability of a garage is 64%. Okay, and then 21% have a swimming pool. So the probability of a pool is 21%. And then 17 have both. So that would be the probability of a garage and a pool is 17%. Now the authors also promote the idea of always making a picture whenever you can. So what we're going to do is go ahead and make a picture of this situation. And we're going to use a Venn diagram. Okay. So let's call this circle. Let's let this be the probability of a garage. And that's going to be, the whole thing is going to be 64%. So I'm going to have to subtract off 17. And I'm going to get 47. So I'm gonna go with decimals here, 0.47, and so it's going to be a little tight, but this would be 17. So 17 and 47. Sorry about that, it doesn't look too good, but 17 and 47 add up to 64. So this would be, let's just call this garage. Okay, and then the probability of a pool is 21%, but we also have to subtract off the 17. Okay, so that's going to be 4, right? 0.04. If we do it this way. So 0.04. Okay, so this is a Venn diagram, and if we think about it, if we added these all up, we are short 0.32. So 0.32. That would be, I guess, the homes that have no garage and no swimming pool that are for sale. Okay, so this is the situation. So now we should be able to solve the problems. Let's look at the first one. We want to know what's the probability that a home for sale has a pool or a garage. So there we can use the addition rule. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of both A and B. So this is the general probability rule. So for us, I'm just going to rewrite it real quick. Probability RA is going to be G, a garage. Actually, they say, be consistent, they say pool. So the probability of a pool or a garage. So that's going to be the probability of a pool plus the probability of a garage minus the probability of both. Let's just use a little shortcut right there. So probability of a pool is 21%, 0.21, and the probability of a garage is 0.64, and the probability of both is 0.17. So that's going to be 0.68, or essentially 68%. Okay, so the reason we're subtracting this off is that these are not disjoint events because there is some overlap. And what we can't do is we can't add these both, because now we would add the 17 twice. So we have to, if we add the amount for the circles, then we would duplicate the 17. We'd add it twice. So we have to subtract it off. The other way is to say the probability of P or G, and you could say by the diagram, it's 0.4 plus 0.17 plus 0.04. And you're going to get the same thing, 68%. But here you would want to say by the diagram. Okay, so this is problem A. Now let's look at B. B says we want the probability of neither. Well, we've already done the work. That would be all of this area, right? All of this out here, homes that don't. So that's just 32. So the probability of neither a pool nor garage, that's really, if you think about it, it's 1 minus the probability of a pool or a garage. So it's going to be 1 minus the sum of all those things, which we know is 0.68. So that's going to be 0.32, which is 32%. Okay, or you could just say by the diagram it's 32% because you've already done the work. Okay, last problem. See, that was B. Oh, let's do C. A pool but no garage. The probability of a pool but no garage. This one's a little bit harder to look for a model to use. So let's just see if it makes sense. We want the probability that it has a pool. Okay, that would be right here, right? The probability that a pool, but no garage. So we would have to subtract 17 off. Okay, so that would be the probability of a pool. Probability of a pool minus the probability of a pool and a garage. Okay, and then that's just going to be 0.21 minus 0.17, which is 0.04, or 4%. Now it would be okay, you could just say if you wanted 0.04 equals 4%, and if you want to just say by the diagram. So for all of these you could say by the diagram, providing you make a diagram. Okay, so I hope that helps with this problem. Good luck.